the previous video, there were no visual aids used, but if you were to use a visual aid on a piece of paper, which one would you choose? I would choose a Cartesian system, like this. I have two axes which are perpendicular to each other. Now, how would you use the horizontal axis? For which dimension? What would you use it as? Which variable? I would use the time, t. And which variable would you use for the vertical axis? I would use the variable v for velocity. And which units would you use for t? I would use, for example, minutes. And I would say that would be 10 minutes, 20, 30, 40, 50, 60 minutes. We had a track that was going for a total amount of 1 hour. And let's put, which units would you use for v, velocity? I would use kilometers per hour. Kilometers per hour, because these are the units that we used on the previous video. And let's put 60 kilometers per hour right here. So how would you describe the initial condition when the truck was moving at a constant velocity of 30 kilometers per hour for a duration of 1 hour? Actually, I would describe it like this. You see the velocity is constant, and the area of this rectangle represents the total distance covered, which in this case is 30 kilometers. Now in the next scenario, the truck didn't move at all for half an hour, and then moved for another half an hour at a constant velocity of 60 kilometers per hour. So how would you draw it on this graph? I would draw it like this. Here it does nothing, and then goes up like this, and it comes back down. You can see that the area of these two rectangles is the same, and this is because the distance that was covered in both these scenarios was the same. Now, another option would be that the truck didn't move for 20 minutes, and then for another 20 minutes it moved at 30 kilometers per hour, and then for another 20 minutes it moved at 60 kilometers per hour. And how would you draw that? Actually, I would need a different colored marker for it, which I do not have. So you'll have to work with me here. So truck didn't move at all for 20 minutes. Then it moved for another 20 minutes at this velocity of 30 kilometers per hour. And then for another 20 minutes, it moved at 60 kilometers per hour. So we have this shape that looks like this. And you can again see that this is the same area as before. You can take this little chunk here, move it to here, and you get the same rectangle exactly. So this is how I would use a visual aid for the previous problem. And obviously the idea of a constant acceleration would make it look something like this. In this case, the acceleration is completely constant, and you can see that the area of the triangle is once again the same as the area of the original rectangle. You can take this little triangle here and move it to here, and you get the original rectangle, which shows that also in this case the distance covered was the same. And this rectangle shape is what happens when you drop a ball out of the window. Okay, this is enough for now.